lithium here, how are they going to mine it? They're not going to mine the water here because there is not that deep brine water, and the concentrations are not high. And they're not also finding pegmatite here, which is another source. So where will they find? Where likely would they find the lithium in the Playa?
Well, we'll see in another slide, but I want to say there are no lithium or beryllium pegmatites in this part of Arizona. There are some dikes, which is what you call the same shape as a pegmatite. That would be from basalt dikes, D-I-K-E-S. The ash might contain some, but the ash would be in the chiricahuas. If they were to pump out the shallow groundwater, assuming there's lithium in that salty water, a well could not go any deeper than about 100 feet. And then the area that a well extracts doesn't expand out very far from that well. So they would have to put in, I would say, hundreds of little tiny wells taking water from the top. And as they took water from the top, water from the sides would run into to fill that empty space. So the overall result will be water table dropping. Now, I did say earlier that lithium likes to hang on to clay. So let's see the next slide.
Thank you.
Which was what I picked up from Max Power. First of all, they call this a clay stone. This is not a clay stone. A clay stone would be hard rock. This is just clay. And this is clay that they pulled up out of a borehole in the Playa. Now, there's a couple of interesting things that as a geologist, I look at this clay. Because I used to do a lot of drilling and put my drill cores into a core box just like this. The first is the color. The color is gray blue. When I would interview young students for potential hire, I would hand them a core that was in a plastic sleeve. And the bottom would be gray, and the top would be red. And I'd say, why is this? Why is the top red? Why is the bottom gray? And the answer is, when clay is exposed to water and air, it turns red, dark brown. When it's fully saturated all the time, it stays gray blue. Now, we know there was Lake Cochise that was depositing clay, but not for very long. And if you go just to the west, to Benson, in Benson, they have 400 to 600 feet of clay underneath in their aquifer. And as you drive on I-10 through Benson, you'll notice that all that clay is red, orange, brown, because the clay had been exposed to air, atmospheric to oxygen, as the clay dried up. Now in Benson, there was a lake there for a hell of a long time geologically. And that's the only way you can deposit 400 to 600 feet of clay. Underneath that clay, there is an alluvial aquifer, and because of the weight of the clay, the pressure pushes the water, the groundwater in that deep alluvial aquifer, up to land surface, artesian wells to the southeast of Benson. And I've been looking at those wells on the ground since I've been at the university here. So that's over 20 years. And you can see in the beginning, the water went all the way up and into the sky. Now the water is just bubbling over the well because over time the artesian pressure goes away. So what this tells me is that this is lake clay from Willcox. We don't know how much they drilled. Maybe they only drilled this top 20 feet or so. They say that the assay is pending. And from the boring number, I'm presuming it was drilled in 2023. Now, they had named an assay office that was doing the lithium analysis. And so I called them. And the assay office is in Tucson, but they do not do the actual analytical work. They send all of the samples up to Reno. So I talked to Reno, and Reno said, depending on how detailed we want the analysis, it will take between 5 and 15 days for the lithium concentration to be reported. 5 to 15 days, 1 to 3 weeks. So what this means to me is that Max Power already knows what the lithium content is, and we have not been told. Next slide.
Let me, can you hear me okay? Is this mic working?
Oh, yeah.
Hold on.
I can hear you.
Okay, I was just going to say is, Kristine, I think it's worth pausing here for a second because I just want to make sure everybody in the room knows Max Power is a company that's currently doing exploration. They're not the first exploratory company to be here. There were a couple others back in the early part of the 2010s up to 2016. Most of that was done on the northern end. This mining, these core samples were taken along the southeast edge of the Playa, and they continue to do that exploration. They say they're in their third phase. Actually, I think they either just announced their fourth phase of exploratory wells, drill holes. This is, I think they're doing about 3 drill holes per phase. These came from, I believe, phase 1. Yeah, phase 1. Phase 1. So just to put that in perspective, as Kristine is saying about these assays, so when they pack these up, they're going to send these to a lab. They sent them to Tucson, but then that lab sends them to Reno, Nevada for further notice. Well, we know we can drive to Tucson an hour and a half, deliver these samples. They can then probably FedEx them or UPS them to Reno in a couple days, right? These first core samples were drilled last year. So do you think if someone was sitting on top of a literal gold mine in terms of lithium, that they would be holding that back? So we'll talk a little bit about why they may not be revealing the concentration, but you can probably figure it out in your own mind. Thank you, Kristine.
But I also want you to notice that all of the press releases from Max Power is generating their, and you'll see it in small print at the bottom of every press release. They are addressing acquiring lithium exploration permits. And the most important reading you can do with Max Power, with everything they put out, look at the very last paragraph of every document. Because they are an investor group out of Canada, they have very strict rules in Canada, which we do not have here in the United States, about what you can say when you're trying to sell
let me just show the audience here something here quick, Christy. So if you go out on Max Power's website, they're hyping all this. They have some nice videos and all, but then they have some press releases that look like this, pages. And what Christine is saying is, you go to the very last page, that press release, you'll see that whole page. This is what's called a forward-looking statement cautions. And it lists everything that you should be careful that they said earlier. It may not be true. Okay, go ahead.
And that's a Canadian law.
And that's a Canadian Securities Exchange, because they are a Canadian company, so they have to. Okay, next slide.
Next slide. And this is also from Max Power, who put on several American flags. So we know that even though they're Canadian, they respect the flag. And so they also say this is the first ever Willcox Playa systematic diamond drilling. Every drill has diamonds in it. So what they meant to say is it's our first ever diamond drilling. They're using interesting language to make you think how spectacular they are. Now, what I think is interesting and why I included this image, you know, in addition to all of those American flags in the background, is that if there was a lot of lithium, we could not have all of those irrigation circles. And they identify the source rocks with those white circles all around. Now, here's the question.
Wait a second, Chris.
If those
So those in the room, can you see these they've put these white circles with the blue around them. Those are supposedly to demarcate the source rocks. I suspect this is Three Sisters here, and then probably the Dragoon Mountains there, and Dos Cabezas and so forth. So they're saying the source rocks for the lithium came from those mountains, basically. Sorry.
Yes. Now, here's the question. If that's the source of lithium, why don't they mine there? That's my question.
No one here has an answer for you. They're stupid.
They're what?
I said, no one here has an answer. You stumped them.
Yeah. And, you know, if there was that much lithium in the water, why aren't we killing all that agriculture?
So let me just clarify on that. So remember, you know, if the lithium washed out of the mountains when the granites were decomposed, you know, over time from rain and so forth, and washed down into the Playa, and that brought that much lithium on the surface, that would be killing vegetation as it went, you know, and that's the whole idea. If that concentration was that high down into the Playa itself, it would have been devastating to the vegetation in the valley.
And also, if in fact that clay contains a great deal of lithium, and the reason why lithium likes to hang out with clay is that it's similar in elemental structure as magnesium. So as lithium is moving through clay, it'll say, hey, magnesium, I want to take your place. So I speculate that Max Power is hoping they will find high concentrations of lithium in the clay in the Playa, but know that the previous research said if you have lithium dissolved in the water as it runs over the surface, within 2 miles, all of that lithium will have already joined up with clay already pre-existing. So I didn't want to show, and Steve knows this, I didn't want to show any Max Power things, but this one really moved me. Next slide. Okay, so let's talk about something we all know. throughout the Willcox Basin. And this shows it has been dropping since the 60s, going down, going down, going down. Water table has been dropping for quite a while. And you add on top of that the additional Riverview pumping, where they're pumping even more. And these numbers are, again, from ADWR from 2018. And this hydrograph, which is a graph of water table elevation over time, only really goes up to 2013. So I think you all know you're in a bit of a crisis as far as water supply in Willcox. Next slide. And the other problem with pumping groundwater, and this is the results again of the groundwater modeling before Riverview, that there will be a maximum of 6 feet of land subsidence. And you can see the map to the left where they show the two areas where land subsidence is predicted within the next 100 years to drop 6 feet. These also coincide with the previous maps that showed water table drawdown. Now, what's interesting, besides the fact this was before Riverview, is that California was one of the first locations where people realized that pumping groundwater could make the land subside. And in California, in the valley there, it subsided 29 feet, resulting with canals changing direction. Now, even a few inches will break the foundation of a home. So you don't want land subsidence. You don't want to be pumping so much water that you don't have any water and your land subsides. Next slide. So let's talk about some of the research that's being done for enhancing groundwater recharge. And these, I've been working with the USGS recently on a site along the eastern boundary of the Willcox Basin. And these images are from a landowner who had already put in a number of leaky weirs, also known as gabions, across existing washes on his property. Now, his goal, if you look at the bottom where the puppy dog is hanging out, his goal was to slow surface water runoff, to allow groundwater to recharge, but also he wanted to stop the sediment so he could have more sediment contained in that area. So these are two leaky weirs, and they're made out of rocks that were found in the area. Some of them were cemented in, but always the very bottom had either had a drain pipe or the rocks were placed so that water could go through. Because in Arizona, you are prohibited from putting in a dam that would hold the water and not let it through. But if you put in a leaky dam, a leaky weir, or a gabion, you're allowed to do that. Now, I had done some research when I was still at the University of Arizona to look at how much impact that localized recharge could be. So next slide. This is in Arivaca, and that's southwest of Tucson, about 9 miles north of the Mexican border. And here, the landowner, who was a retired sculptor, artist, whatever, and he got metal and he built for the rocks that he collected across his landscape. And he put in these gabions. He also built that little bridge in the background. So he put in these gabions because he wanted to slow down the surface water so he could capture it and enhance recharge. Next slide. This picture is taken from that little bridge you saw. There were a number of hurricanes in 2014 that hit southern Arizona. And this is one of them. And you can see that all those gabions really slowed down the surface water runoff. What a cool idea to try to enhance groundwater recharge. Now, Chris Eastoe, who was, before he retired, the manager of the geochemistry lab specializing in isotopes, he and I started working together on a couple of sites like this. And he had discovered that those hurricanes from 2014 had a unique isotopic signature. So we speculated that if we looked for that unique signature in groundwater in 2016, we could see if this approach had actually recharged groundwater. Next slide. So we sampled all the wells in the valley, and the well at the bottom is the well of our landowner who built the gabions. And the well at the top is his neighbor. The only location in all of Arivaca where we found groundwater recharge from those hurricanes was in the well at the bottom, because he slowed down surface water runoff, slowed it down so that the water could enter the groundwater and recharge. But the effect was only felt in the local area. Now go back one slide. Now look at that. You're going to have to use rocks and either cement them or put them in steel cages. They have to be heavy, because if you tried anything like a tire, when there's this much flow, the tire will start floating downstream. And more importantly, I know here in Pima County, if you put tires in a wash, that's considered illegal dumping. So when you think about building gabions or leaky weirs, you have to think about your construction material. Next slide. No, go back to the one before.
Oh, sorry.
So, and also realize that you're going to put in effort that will only benefit the immediate area. It won't benefit your neighbor. That recharge, groundwater recharge, did not make its way all the way into the Arivaca main aquifer. The owner of the gabions and the well where we found recharge, he was up close to the mountains, so he was on the edge of the basin. Nothing made its way into the center of the basin. Now the next slide. Now, Chris Eastoe and I had worked in Arivaca for a number of years. And the other thing to consider when you think about recharge is seasonality. When does it rain? And does that rain recharge the aquifer? Now, look at the top graph. The red line is depth to groundwater. And you'll see, and this is from a well that was at the bottom of the basin, downstream. right next to a stream. Depths to groundwater varied between like 10 feet below groundwater to maybe 15 or 17 feet below groundwater. So the red line is depth to groundwater. The blue line is precipitation, when it rained and how many inches of rain. Now here's an interesting sidebar. We got our rainfall information from the rain gauge in Arivaca, which was in the post office. And did you know, according to the post office data, it never rained on Sunday. They only had data from Monday through Saturday. So here is our rainfall data. And you look at the red line on top. And when all of a sudden the depth to groundwater moves from 15 feet up to 10 feet below groundwater, meaning there was recharge, it was only after there was about 4.3 inches of monsoon rain prior to any groundwater response. Now, know that this is shallow groundwater. This is shallow groundwater. So let's look at 2008, the monsoon rain. And we had another response. Depth to the water table was going down from 10 feet to almost 15 feet. And after 3.4 inches of rain, the water table jumped back up again almost to 10 feet below land surface. Now look at 2009, which I call the non-suit. There was not a lot of rain, but it tended to rain later in the season when the plants and the weeds were capturing any soil moisture that was moving through the subsurface before it even reached the water table. And it just never responded. We went from about 12 feet below land surface to 16 feet below land surface. No groundwater recharge. So keep that in mind about recharge. Recharge depends on how much water and what is the season. Now there have been proposals in the past, for example, to cut down all the trees that are around the Grand Canyon so that the water won't be captured by the trees and it will recharge groundwater. There was also an effort, and I want to say this was 30 or 40 years ago, where they flew over the area east of Globe and they sprayed Agent Orange to kill the vegetation, to enhance water runoff. Now, in addition to causing a cancer cluster, it did not really measurably enhance water recovery. So you always have to think about vegetation, seasonality, how far the water has to go to recharge. In this situation, we were lucky. We got a very shallow well. In your part of the world, the wells are not that shallow. Next slide. And the next thing we have to think about is groundwater age and climate. And know that Chrissy Still and I went around the state and using carbon-14 isotope studies, we were able to measure how long had it been since groundwater had fallen out of the sky as precipitation, as rainfall. And San Pedro Valley, 11 to 12,000 years ago. The climate was different back then. The glaciers that were coming north from Mexico were melting. Phoenix, 10 to 12,000 years. We also threw in the Rio Grande Valley because I think it's kind of cool. It's 24,000 years. I recently got an age in Patagonia of 23,000 years. Tucson, 300 to 10,000 years. If you drink from the water fountain at the University of Arizona, that water is 10,000 years old. Now, if you come up where I live, up at I keep forgetting this.
The Rito?
The Rito. The reason I keep forgetting it, the Rito means little river. And so when you say Rito River, you're saying Little River River. But up close to the mountains, where there's big boulders and there's not much fine-grained materials or clay, water goes in more rapidly. And so right along the edge of the mountains, it first enters the aquifer, and we measured 300 years old water. And then recently, when I was working with Laura Norman at the U.S. Geological Survey, and we were taking samples along the far eastern edge of the Willcox Playa, just underneath the Dos Cabezas. Am I saying that right?
Cabezas.
Cabezas. Man, just shoot me. We got groundwater ages, and we were still in the foothills, not in the playa. 5,000 to 10,000 years old. Now, I want you to think about this, that this was when mammoths were roaming around, and the water would roll off a mammoth's back and then hit the ground and eventually make it into the aquifer.
And now we're drinking that water.
Now we're drinking that water, and let's hope that mammoth had some good
Hygiene.
personal care practices. Yeah, but it's, there can be, we can use several different isotopes, and we have found very small concentrations of more recent water in some locations, but it's not enough to mean anything. Majority is 10,000 years old. So, next slide.
Kristine, before you move on to that, can you just speak to, I know like in Tucson and areas around Phoenix, they have the Central Arizona Recharge, Colorado river water that's being recharged in the aquifer. Explain how that is done, because that must be done differently if it's taking that long for the water to actually reach the basin.
Yeah, I was lucky enough when I first came to Tucson to be part of a project to measure how long it would take for water in the recharge basin to reach the water table. And we put in several instruments and found it took between 2 to 3 years to make it down to the water table. And their basins they're managed with goats and with backhoes to, make sure there's not much clay clogging the basins. They never hold more than a few inches of water because otherwise it would all evaporate. And so they are introducing more water into the Tucson aquifer that way. But when you look at how much water there was going in 10,000 years ago, those recharge basins are just kind of keeping up with demand. There's not enough water in our climate to overcome the overdraft of our aquifers across the state.
And aren't there some recharge areas where they have direct injection wells, but that's very risky? Can you explain that?
Oh, yeah, up in Payson. I love Payson. They have an agreement with the SRP, Salt River Project people, who, as you know, have a very heavy hand on water usage up in that part of the state because and they have a reservoir, and I forget the name of the reservoir, but they allocated a certain volume of water to be going to Payson on a regular basis to provide water supply. And Payson doesn't use it all. So they put in groundwater recharge that consists of injection wells, wells that directly inject the reservoir water into their aquifer. And that's a very cool thing. However, you must be careful about the water quality of what's going in, because you don't want to be introducing any excessive bacteria. Even a temperature change can change water quality in the subsurface. So they're monitoring it very well. So Payson is cool.
Good. Thank you. I think with that,
Next slide. That's it. Now, open.
okay. So we can open up the questions. I have a couple questions I'm going to ask Kristine relative to Max Power and the lithium situation here. First of all, clarify for us, Kristine. So basically, based on what we've seen and what you could potentially believe from Max Power and what we know about the geology, probably the only possible option for mining here would be extracting the clay soil out of the playa for the first 100 or so feet. Is that what we're saying?
Correct, and it would be a strip mine, but I'm concerned because they've had those samples for several months, and they have not reported to their potential investors what the concentration is.
Why does that concern you?
So they're asking a question, why does that concern you? Do you want to speak to that, or do you want me to answer that? Kristine's a little sensitive on this, so I don't want to put her on the spot.
Well, no, I'll answer
Okay,
that.
okay, she'll answer.
Whenever you're reporting on environmental conditions and you're trying to encourage people to invest or even just accept your activities, you should be honest. And it's the fact that Canada has rules that the United States does not. And when they follow their rules, for example, they keep reporting that there was a USGS well number 1 that had lithium in clay at concentrations over 500 parts per million. Or actually, it was milligrams per kilograms. But they report in the small print that this data was not provided or supervised by a qualified person as defined in NI 43-101. That's a Canadian law that says that if you are proposing investment in a mining effort, N1 43-101 requires or identifies a qualified person, a minimum having 5 years of experience.
Do you want to put Kristine on the screen?
Now they're claiming this is USGS well number 1, by which for several weeks I've been having friends at the USGS and friends in Texas looking for documentation of this well, and we found nothing. So by Max Power stating that this data can't really be trusted because it's not presented by a qualified person, and then claiming it's from the U.S. Geological Survey is the #1 qualified entity in the United States. And the USGS is a public agency that requires all of their findings, their drilling, their analytical results to be made public. And we can't find that public data. That just makes me feel uncomfortable. Now, we know that there was, and Steve found this, there was a company called, what was it,
Pueblo Lithium,
that put in a well in the Playa in 2011,
north of the railroad tracks.
north of the railroad tracks. They sold the well to another company whose name I can't recall, who then said, this isn't worth much, and they shut it down. So, I don't know where Max Power got their data from Table 1, and they say up front it was not supervised by a qualified person, but they claim it's from the USGS. I'm just too confused to accept any of it. Do you want to add anything, Steve?
I would just say, I think right now their strategy is to string potential investors along as they can, just hoping they will find something. If you look at the description of this company, they don't say anything about mining. They're an exploratory company. So it's all about, I'll use the word hype, because the more excitement, the more hype they can build around a potential discovery, the more investors potentially they can attract. Kristine and I aren't going to come up here and tell you that there never will be lithium mining in the Playa. Economics can change and so forth, but based on everything we've talked about, everything she's presented today, what we see from Max Power, we know other people have drilled here and not found it. It's very unlikely it was that much different on the north end of the Playa where the original lithium mine was. So we're guessing right now they're just stringing it along and keeping us nervous, but we'll keep watching. I mean, I think that's what we all have to do. And remember, this is not a proposed mine. There's no proposed mine at this point. This is just exploratory. And a proposed mine would take years to get permitted and so forth, a proposed mine. But we don't think this is going to go anywhere based on current information and based on what we know of the geology. You want to add anything to that, Kristine?
This is very common in the mining industry. It's called pump and dump. So you pump up the potential value and then you sell it to somebody. And so it's just a big way to manage money, collect money. That's what they did up in Sholo with the potassium and the salt. They pumped it up, and then it just got to the point where everything went away. They got a lot of money from investors, but that money went away.
Right, and I think you told me the other day that you were just asked to be or provide some information on a potential lawsuit by investors in Texas on a maybe a similar type of situation?
Well, I won't be working on that. That was, remember, our first frustrated volcano, Round Top Mountain in West Texas near El Paso. I had been working with them a little bit when I was in Texas doing our big lithium research, and they were doing similar publicity, pumping up, and now they are being sued by their investors. So who knows what's going to happen. It's the standard process in mining, like what's happening in Rosemont, which is no longer Rosemont. I think it's called Copper World or something. Is you pump it up, and then somebody else will come along and say, oh, I'll buy that. And you don't know what the future will hold. It all depends on how much profit you can make or how much you can pull in from investors.
So we've got a bunch of questions. Let me just start working through some of these. Some of them are I think duplicates, but that makes sense. People have questions. So one person asks, says they have top water at 183 feet in a 500-foot well after it rains in Cochise Stronghold. Now, Cochise Stronghold is a canyon area actually within the Dragoon Mountains. After 7 to 10 days, there seems to be recharge into fissures. Is that possible? Is that what's happening?
Yes, recharging in bedrock fissures is possible, but also whenever I see data like that, I have to see the wellhead, because often what's happening is that surface water is ponding around the well and seeping down into the well along the outside casing. So you could have what appears to be recharge that is, following a recent precipitation event. But yes, when you have fractured bedrock, the water can travel rapidly through the fractures to get down to the water table. And then it can move out just as quickly.
Thank you. Next question is there any way for someone to know how long the water supply will last in our area with the current use?
It depends on who you're talking to. If you're talking to a real estate agent, don't worry, we've got so much water. If you're talking to me, I'm going to say, what is your time frame? Because I know when I talked to the manager at Riverview, his concern was that his business plan was for a return on investment in 30 years. And I said, you have very deep wells. You will have water for 30 years, but nobody else will.
So it's a very complex question. The bottom line is the more we use, the deeper it gets. So if you can afford to go deeper, you're going to have water longer. If you can't, you're not going to have water for long. But I will say this too, Kristine, and maybe you can comment to this. You had the one slide up that showed kind of the reverse contours of what the basin looks like underneath. Some of those are only like 1,400 feet. Some are only 400 feet. So if your well is 400 feet and that bedrock is below there and you can't get any water out of the bedrock, I mean, if there's no fractured water coming into that bedrock, you're probably going to be out of water completely. You're never going to have a well that functions.
Yeah.
Whereas if you're in the deepest part of the valley, which is where most of like in the Kansas settlement area, east side of the Playa, they're going to have water. They're going to have deeper water for longer. Go ahead, Kristine.
Well, you think of the bottom, it's like an egg carton with highs and lows. And if you happen to have a well that is able to go deeper before it hits bedrock, you'll have water for longer. But don't rely on recharge. You're just not going to have much recharge unless you have a wash that goes through your personal property. You put in leaky weirs and or gabions, and you use that water, which is very local to you. You'll have water longer than your neighbor.
Good. So someone related to someone asked the question, could dry wells be built to collect runoff before it gets to the Playa where it just evaporates?
This is what happened in Phoenix. In the beginning of development in Phoenix, they said, what should we do with all of this rain runoff during monsoons? And they said, let's build a bunch of dry wells so it collects all that water that's running over the streets and picking up all the contaminants and put it directly back into the aquifer. And all of that water is contaminated, and the first part aquifer in Phoenix is heavily contaminated. Do not put in a dry well with the intent of recharging unless you have very good control of the water that is going in. And I would not recommend collecting rainwater that is running over the landscape to put into a dry well. It needs to filter through the sediments to take out the oils and grease and some of the other contaminants.
Okay, it's a quick question I can answer for folks. Are the wells in the Cochise Stronghold connected to the Willcox Playa aquifer? And the answer would be yes, correct?
Yes.
Okay, I passed that one. All right. Okay, let's say, here's a good question. If it turned out that the soft clay in the Playa had profitable concentrations of lithium and mining operations were initiated, what might be the possible impacts on surrounding water quality, air quality, or otherwise? What should we be concerned about if something like that happened?
Number one, I would be concerned about dust. I would be concerned about more trucks. And it will lower the water table throughout the basin. And it depends on the method they use as to how much water they might need. Now, it is highly unlikely that they will have evaporation ponds. The reason they have so much information in their propaganda about the USGS is that back in 76, there was a valley in California called the Clayton Valley that they found a huge reservoir of high lithium brine at the bottom of the basin. And they said, oh, we have to see if we can find this anywhere in the West. And so they used a method where they flew over Clayton Valley with an airplane that would measure geophysical signatures, resistivity, gravity. And then they flew over a bunch of other basins. And they flew over Willcox. They did not put boots on the ground. They just flew over the basin in an airplane. And they said, oh, the results kind of look like what we had in Clayton Valley. And then they speculated that there was a deep brine body, which we know does not exist. But they speculated that that brine body, the same thing that we have in produced water, was to the northwest of Willcox. So because I used to work with the USGS, because a lot of my friends are USGS, I get really sensitive when the USGS name is abused.
So has anyone seen the airplanes flying over recently in straight lines? So I don't know the details of that, but it's definitely some kind of survey. It could be a similar kind of geophysical survey where they have a probe on the back that's sending like a type of, I'm probably not saying it right, X-ray, LiDAR.
No, it's not an X-ray.
It's not X-ray, it's not, go ahead.
No, and ADWR was doing that across the state about 10 years ago. They might be doing other basins they haven't looked at.
So the bottom line is the initial thing that got people thinking there might be lithium in the Willcox Playa. I mean, there's other reasons potentially, but was this USGS report that was what, from early 70s, Kristine?
1976, and what the USGS report consisted of was every chapter was a different paper originating from the USGS on the general topic of lithium, where they talked about pegmatites in the Carolinas, Clayton Valley, the Salt Lake. Every chapter was a different topic, and only one of those chapters addressed Willcox.
And the bottom line is all that data came from flying overhead. And they even said in their conclusions, Kristine just sent that report to me a few days ago. And even in their conclusions, they say, you know, there's a lot of potential there's a lot of room for error in this data.
Oh, yeah.
And they, apparently, obviously there is. There was a question I think relates to this because in phase one of the max power propaganda, I guess we'll use that word, they mentioned something about a step out of 6,000 feet. I think the person that wrote this comment misinterpreted just like I had, and I think many other people had. When they saw that, they thought they were drilling to 6,000 feet. I've reread that a number of times now, and when you look at some of their other data, they kind of intersperse those numbers, but the 6,000 feet is the distance between their wells, not the depth of those wells. But we think, which Kristine and I talked about this little, you know, to kind of keep maybe some investors thinking, well, maybe there's brine water under there deep. You know, she talked about the deep water. That might be what they think people are looking at, but they're only going 1,000 feet basically with most of their wells.
Yeah, and there's no deep brine water.
Exactly.
There's been enough drilling in the Willcox Basin. There's been enough understanding of the geologic development of the Willcox that it's fresh water on the bottom, salt water on the top 100 feet near the Playa. And know that what's going to happen next is Max Power is going to pump up this investment opportunity until somebody else buys it out, and that's where they make their money. That's where all of these mining speculators make their money.
Well, if there's nothing there,
Okay.
it's a moot point.
So,
They're gonna drill all the holes they wanna put.
any information, if you have dust from the lithium, is the danger in the lithium, is there any carcinogenic quality to that dust? Do we know, or I know you're not an epidemiologist or that, but are you aware of any issues with that? Because dust is definitely an issue coming off the Playa. And I will say that if they're doing the mining of the clay, it would be a strip mine. So basically the Playa would go away as it currently exists. And I would think, you know, with all the earth moving that goes with that, we're gonna see more dust. I mean, I think that's common sense. I don't know what kind of mitigation they would have to put in place to cut back on dust, but can you talk at all about that, Kristine?
Well, the dust danger will be in the actual particulates. The particulates. Lithium, if you breathe a lot of lithium dust, you'll just be a happy, peaceful person.
Okay. What's the, when you look at that pegmatite in Australia, what are the concentrations of that? I mean, that must be highly concentrated lithium, correct?
Oh yeah, that's pure crystals of lithium. And I don't know what the overall concentrations are, but they're high enough that they dig them up, they ship them by boat to Texas, they send them by rail to San Antonio, where because it's a solid, they have to grind it up and use various chemicals to leach out the lithium.
So it's an involved process once it is taken out.
Oh, it's very complicated.
Okay. One of the questions came up that the issue of sustainable use of water is not popular among policymakers because good estimates would suggest need to limit growth. I know you've told me many times you're not a policy person, but do you want to speak to that at all?
And I also see in the chat, if Riverview left the valley, do you think we would able to recharge? No, it's already too late. You're already in overdraft. The last time there was enough water in the climate to fill up the aquifer was 10,000 years Now, if we have more rainfall, we might start increasing recharge. But in terms of sustainability, um, you have to manage how much water you're pumping and for what use. You have to prioritize your water. And I would like to add, you have to give ADWR more power and authority, because right now, any person can report a geologic log, and that person does not have to be a geologist. Any driller can submit a drill report that is full of blank spaces. A notice of intent to drill full of blank spaces. And ADWR has no choice but to allow them to pull forward. Now, there was a methodology that was developed by Colorado back in the early 1980s. And I know this because I was working in water law in Colorado back then. And they had a procedure that they would not allow a new well until you reported what the impact of your new well might be on your neighbor's wells. And that was the basis by which they would authorize a new well or not. There could still be continued drawdown and overdraft, but it would not be like what has already happened in Willcox.
Yeah, I will say that well spacing requirements are included as part of the AMA legislation.
Well spacing isn't enough.
Yeah.
The analysis that was required in Colorado was you had to report on your well depth and your total usage and how much you would use over 100 years. You would then draw what your drawdown would be around your proposed well. And if that drawdown interfered with anybody else's pre-existing well, you would have to subtract their pre-existing water rights from your proposed future water use. So it required that each drilling company not only have a geologist, but would access a hydrologist, which is the work I was doing back in 1981 to determine what neighboring wells could be losing their water supply because of the new well.
Thank you. So this might be a good question, and I know there's a few more questions. We'll try to get some answers to some of these and send them out if you've signed on our contact sheets. Send out that information along with the presentation. But someone's asking, where in the U.S. would you recommend moving to have a decent quantity and quality of water supply?
I came to Arizona because I like the geology, but in terms of water, well, I know New York City has a beautiful reservoir-based water supply that they have really protected, and their water quality is good. I would not move to Atlanta because their water supply is based on a reservoir that dried up several years ago and then it came back. I would just suggest that you look at what's available, but know that groundwater is not routinely recharged like a checking account. Like if you have a checking account and every month your salary goes into it, and so you keep getting recharged to your checking account. What we have here in Arizona is a savings account. Water is not going into the aquifers, so we're living off of our savings. So basically, I don't know. Wisconsin has a lot of rules about water use. Minnesota does too. That's why the dudes from Riverview moved out of Minnesota to come to Arizona.
What's interesting is I did a lot of door-to-door, going door-to-door to talk to people. I didn't know about the water situation, and I can't tell you how many people, when they explained to them the water law in Arizona and how it works, said, I'm from Oregon. We get 45 inches of rain here, and we've got more protection than you have. I think
Yep.
most people were shocked that have moved here from other places to find out Arizona was so in rural Arizona. And you got to remember, rural Arizona was specifically exempted back in 1980 when the Groundwater Management Act was passed. It was part of a compromise because they couldn't get all the votes they needed otherwise. So that's something we're all living with, that mistake here 44 years later. So
I think the only thing you can do is give more power and authority to ADWR to refuse new wells when it is established that that new well would interfere with pre-existing water supply.
right. Well, Kristine, it's been a pleasure having you. I'm glad everybody stuck around to the end. Took us a little longer than we thought. Sorry about the technical issues early on. I just want to make a couple comments. If you haven't signed up on our contact sheet and you want to stay abreast of what we're learning that's going on both with the groundwater situation, both here in the Willcox Basin, but also at the state capitol, sign up for Cochise Groundwater Storage. And Lisa in the back has that. And then and either way, I think whoever is interested in groundwater also has to be interested in the lithium because they go hand in hand. We didn't talk a lot about the water use, but no matter how they mine lithium, there's going to be water involved. Maybe not in the mining, but in the processing, and that's going to be an impact. And you heard Kristine talk about what would happen if they did a strip mine here and started taking the clay out. The other water on the edges seeps in, starts to flood that, and that draws down the whole aquifer. So there's implications for groundwater. So Joanna Seeley's the person to see, and the people to Playa, make sure. And we really
And
thank. Yes.
Steve, if anybody wants to contact me, feel free to give them my email or telephone.
I will say Kristine is so gracious with their time. I feel guilty sometimes taking up time.
I don't like to be retired. I don't like to be
Yeah.
retired.
But yeah, she's being sincere when she says that. So
I
thank you
need
so
to
much,
ask a
Kristine.
question.
No, Victoria, no.
Yeah.
So thank you, everyone. Thank you, Kristine.
Turkey Creek is on the corner of the Max Power map.
Appreciate
Is that
it.
where they're getting the water? Why didn't that come up?
I'm sorry, Victoria, you could have brought it up earlier.